new skeleton to study. Any clues that Spinosaurus may have been aquatic. A full century after Ernst Stromer first studied and described Spinosaurus, Nizar and Paul finally have a new skeleton to study.
Extremely exciting to hear that there was a skeleton out there. It's just like, wow.
Paleontologists have been awaiting the discovery of a new Spinosaurus skeleton ever since the first one was destroyed.
Now just imagine if we lost all of this in a single night.
Yeah, well, if there's any threat of a bombing raid here, we are hiding these fossils in the deepest cave.
Just to be safe, the first order of business, copy the bones. While Stromer described all of his bones by hand, Nizar and team use a CT scanner to digitize theirs in, bone by bone, producing a three-dimensional picture accurate down to a fraction of a millimeter. Back in the lab, paleo artist Tyler Keeler then manipulates the hundreds of files and begins assembling a virtual Spinosaurus.
We have just now moved into the digital age for dinosaur reconstruction, in the sense that you can go literally from a bone to a digital model of the bone to a digital skeleton, which you can simplify enough that you can make it move, you can make it walk, you can ultimately put skin on it.
The skeleton is about 40% complete, a surprisingly high number compared to most specimens.
Very few dinosaurs are known from a complete skeleton. There are lots that are known from a toe bone, a tooth. In most cases, just distinctive enough to just tell you, yes, there was something there, but that's all there is.
The digital model allows the team to take their skeleton much further, even incorporating some bones they don't actually have. Using scans of Stromer's original photos and resizing the bones to match their specimen, they can add in bits of jaw and spine that they're missing.
For the parts on the back that we didn't have, we're looking at Stromer's figures to fill those in.
That's a Stromer specimen.
Right, those are Stromer's.
Scans of Suchomimus, Spinosaurus's croc-snouted cousin, help fill out the skull.
Here's actually the Suchomimus brain case, fills in the back end very nicely.
Scaling and incorporating bones from other specimens, they up their total from 40 to over 60%. Then, it's a matter of fitting the bones together. Just getting the jaws to close properly takes 14 days.
Our knowledge of Spinosaurus comes from several different specimens. These aren't all the same size, and so you can't just, hodgepodge them together like some kind of giant Frankenstein. You have to build a digital model in the computer so you can get all the proportions correct and give us a better conception of what the skeleton of one of these animals would have been like.
Taken together, the new specimen, Stromer's, Suchomimus, and other isolated bones. The digital skeleton reveals an animal every bit as extraordinary as Stromer imagined. 50 feet from snout to tail, the model confirms that Spinosaurus is the biggest predator ever to walk the planet. At least 9 feet longer than the largest known T-Rex.
Size does matter, biologically speaking, because you wonder what are the ecological circumstances that support such a large